Hey everyone, lazy Saturday. Welcome to Retrospective planning for Sprint 2. Well, Retro Sprint 2 planning for Sprint 3. I actually have a demo today. I want to kind of show you what's going on with all of these key names and things that we can do with them. So during the retrospective, I'll give a quick demo. So thank you all for following along. Crazy, over 300 subscribers now. Huge deal for being such a small market, and we'll get this started after the title. Alright, so what we'll do is we'll go into the retrospective. I'll give a quick demo on some table data, and then we'll go into planning. So I would love to hear from you guys. What do you think went well? What could have been improved? And what would or should we commit to in the next sprint? So I'll go first. What I think well was we did quite a lot of work, and my demo will show the kind of power that we've already accomplished. And there were fewer errors. I know in a couple of videos I did make a few mistakes, but such as live development, such as development in general. So I think that went very well. I was able to meet what I said I would commit to. I got 10 videos out in 14 days. So yeah, good stuff. Like I said, love to hear from you guys. What I think could have been improved, a little bit on the quality side. I feel that the 1 video a day, 10 videos in 14 days, was pretty stressful. It was a lot to edit the videos. Didn't have time to make new tunes for the background music. So yeah, I think I might have to push that back a little bit. We'll see how it goes. I mean, us developers, sometimes we just get that burst of energy, and I think it's all about if I can get that burst of energy and make 6-7 videos in a day, then it'll push it so far out that it'll help me, give me a buffer zone. So that's what I think could have been improved is quality. And yep. So what would I commit to in the next sprint? I'm gonna try to get these 10 videos out in 3 weeks. So that's about 1 video every other day. I do like to schedule them. I like to create as many as I can in a day, edit them, add the music, upload them, and then schedule them for release. For 10 minutes of video, it takes about an hour and a half, including rendering time. So it is a time-consuming process, but we can do it concurrently, or I can do it concurrently. So that's what I'll commit to in the next sprint is trying to extend that to 3 weeks, 1 more week. Hopefully it's sooner, but that's kind of what I'm aiming at right now. So for the demo, I'm going to go ahead and pan over to my environment, and I'm going to run this code. So this code is basically the system RCFT. The database RCFT is joined on that. Subject is joined on the database. Data set is joined on the database, and data point is joined on the data set. I did not include process or process parameters in here, but I did kind of extend this code from the data point video. And pretty simple, just applies. I do like using applies because it limits that data set for you. So, a lot of applies. And actually created a piece of code that generated these for me. This is kind of where we are at. We have created an information schema more powerful than SQLs. So we have the system RCFT. Oh, there should be one RCFT base. There we go. And then we have the database RCFT base. So we can say that this is a relational database. Microsoft, it's local, system main. We know what shape it is, the subject. We know it belongs to the reference domain. Oh, and it is a subject. This is the subject tables, and it's an RCFT shape. So we know this is a specific table we're looking at, and it's the subject realm table. And this actual record is representing the availability flag of archived. So now, compared to SQL's information schema, we have such an amazing filter capability. So I want to say it would be type. So I'm looking for main databases only. And let's say I just want to see base tables in main databases. And there we go. So we have all of these columns to filter on, and filtering them on the key name. The key name is meant for developer use only, so it makes our code look readable, so we can extrapolate what is actually going on. Main database type, base dataset type, and we just have this power. And this pattern is repeated in the entire or throughout the system, where we can connect more and more different slices of data to limit things in different slices, in different granularities, the atomicity of an actual question. And I just kind of wanted to show some of how we are going to be using this, because the next sprint we are going really deep into these concepts. So I'm gonna pan back. Moving into planning, let's see, I do have quite a few of the videos planned out, at least up to 040 or 045. And then around that moment, I'm going to fork out into a new series. Because we will be able to continue development on the system, yet be able to create an actual purposeful data management system. So for this upcoming sprint, 8 videos, we have the specific dataset number is the first video, and that is the other half of the physical model. This is how we are going to utilize the relationship table. And we need this done before we can actually use the relationship table. Every table will get their own ID, and it will be in the table's specific data set number column. It'll be the same all the way down. What we're doing right now is just making it a 0. So the second video will be our first view, our base view. And the base view is going to convert str key name and sysref dataset ID and those column names into a system unique name and a more user-friendly name. I mean, to a point. You'll see it takes a little time to actually get used to some of the logic behind it, but it should be pretty good. And the purpose for that is we should be able to select star from base view, base view, base view, all the way down and compile it as a view. Not that we'd want to do that, but we shouldn't get any ambiguous column errors. So system unique is a very important pattern for dynamic construction of things. And that would be number 22, second video. For 23 and 24, 2-part video. 23 is going to be data entry to get our basically prepare for creating the select, base, insert, and update views. And that's what 24 would be, is creating the code to create the base, insert, update, and select views, because they all follow the same kind of pattern. And that will give you insight on how we're using definition table and relationship table. And we're abstracting the concept out, so we don't need a procedure for each. We need one procedure to build them all. It'd be really neat. We can add new views and build them using the code that we already have. So it'll convert this view creator to data entry only. Then we'll move into synonyms because we need synonyms to get rid of the DB system main. We're going to need a synonym builder to work with archive and history data tables. So synonyms. Nope, I apologize. Before synonyms, we're going to work on functions. So that long, select ID where type in, select type from type where family in, select family from family. We're going to make that one line. We're going to make it a nice function, and we're going to make our system build them all for us. So that would be 25, and then 26 would be the synonyms. So we can move all that stuff to interface main, get rid of DB system main in our code, which will help prepare us to create stored procedures that will handle insert, updating, deleting, and putting data in archive and history. So 26 would be synonyms. 27 and 28, table creator. 27 is going to be data entry, similar to what we're going to do for the views, and 28 will be creating a table creator. Finally, we're going to want that because it's going to avalanche development. We're going to need an object creator to progress faster with less time, with less focus on creating objects and more focus on conveying the idea of a higher level data management, which is a very important concept. So that is sprint 3. Finally get that table creator, and we'll be able to insert a record into the subject table, hopefully, and it should create our tables. No RCFT or not, know if we have supplied a parent or not, create the proper keys. Actually it won't create foreign keys or clustered indexes or defaults yet. That's going to have to be sprint 4 where we program that into it, but it shouldn't be an issue. What it will do is be able to create all of our views and functions because we are going to do that before we create the table. So now we're getting into the concept of data management and our table creator, like we were talking about in the intro, in let's say 4.5 hours, 10 minutes an episode, 3 sprints, 9 episodes, including tech debt, 270 minutes. Pretty good, right? So, yeah, 270 minutes. Had to think about that. So 4.5 hours, and we have come this far. So it's fantastic work, everybody, and I can't wait to see what we do in one day's worth of work. So yeah, thank you very much for watching this video. Thank you very much for subscribing, for commenting, for all the feedback, the direct messages on Reddit and on YouTube. It's phenomenal. Thanks again, and I'll see you next sprint.